and also the coefficient of friction, what that actually means. Now, most of you remember that friction is caused by these little microscopic bumps called microwelds, and those bumps actually seat between two touching objects. So if you looked at the feet of your chair, for instance, it wouldn't be absolutely smooth. Your chair would have these little teeny grooves in it like you see down here in blue. And the floor, even though it's wax, would still have these little teeny bumps in it. And so the bumps of the chair here and the bumps of the floor sort of seat into each other or mesh down into each other, and that causes friction. Well, there's a couple different types of friction, and those three types are static friction, which is between two objects at rest. So you think static and still, both begin with ST. And so that's actually the strongest friction, because when two things are sitting still, it gives those bumps time to really seat down inside of each other well. So it's hard to pull or get something going, not only because you have to overcome inertia, but the main reason is because you got to pull those bumps out from one another. Now, sliding friction, that's when two objects are sliding across each other. That doesn't have near as much friction as static, because if you're sliding, the bumps don't have time to seat down inside of each other. So, you know, as you're just sliding along here, you don't have time for these green dots, green bumps to go into the blue ones, and so sliding friction is less. And that's why, believe it or not, anti-lock brakes work, because anti-lock brakes actually stop and start your wheel and allow it not to slide. So if your car is sliding, the bumps don't have time to seat in front of each other, so your car will go a longer distance. But with anti-lock brakes, it will start and stop the car brakes like this, so those bumps are actually having time to go up and seat inside of each other. And so by tapping the brakes really, really fast with a computer like that, with anti-lock brake systems, it makes your car slow down faster. Finally, the last type of friction is rolling friction, and that's sort of the least of all, and that's just when you think a tire is rolling over a surface, it's just barely a few bumps at a time touching the floor. The way we measure friction here, and let me go to the next slide here, is something called mu, or the coefficient of friction. And it actually tells you sort of the ratio between the friction force and the normal force. Now, don't forget, on a flat surface, the normal force is usually the weight, but the normal force is whatever force is acting perpendicular to the surface. Now, most of the time, the more microscopic microwelds or little bumps you have, the higher mu is. So think about it. If your weight stayed the same, let's say your weight was 100, and you had lots and lots and lots of bumps, you'd have lots and lots of friction. So let's say friction was 100 and weight was 100. These both were 100. 100 divided by 100, mu would be 1. But if you had less bumps, let's say, 1/10 of that, you'd have 10, but your weight would still be the same, so your normal force would be 100. Well, if you had a friction force of 10 and a weight of 100, then mu would only be 0.1. So the lower this mu, or this cursive U-looking thing is, the lower that is, the slicker the two surfaces are together. And so the way you get mu is taking the friction force and dividing it by the normal force. If you look at the different mu's, for instance, the mu between rubber and cement is really, really high, but the mu between steel and cement is really, really low. And if you ever look at the guardrails out on the expressway, they're sort of built like this shape of a pyramid like this. And that way the rubber tire hits the concrete barrier first. Since those two things have a higher mu than the steel and the concrete, it actually slows the car down and then pushes it back into traffic that's going the same direction, instead of flipping it over like these old guardrails here that would rub metal against metal and not slow you down as much. So that's sort of an introduction to the coefficient of friction, and there's going to be some other little videos that explain how to do the lab that I want you to take as well.